Now we're going to look at how hybrid orbitals can lead to double and triple bonds. So there are two types of bonds. One is formed by the hybrid, and they form sigma bonds. A sigma bond has overlap on the bond axis. And so what that means is if you have two atoms, and this is the nucleus, or the nuclei of the two atoms, and here's their electron clouds, the bond is where they overlap in between. So the overlap is right between the two nuclei on the axis of the bond. The other possibility is a pi bond, and this is from p orbitals. You need to keep track that pi is from p, sigma are from the hybrid. Pi bonds, a pi bond has the overlap above and below the axis. And so how this happens is that you have p orbitals. Let me draw the orbitals first. And here's the nuclei. And when these two get closer together, what happens is these orbitals kind of spread out to where they're connecting. And they don't connect right between, they connect above and below. So if this has an axis to this bond, that's it, it's right. So this is offset from the axis, it's on either side. And this is why pi bonds can't rotate, because if you twist this, these two pieces would come disconnected. Whereas with a sigma bond, if you twist one, this part stays connected the whole time. Anyway, let's see how this happens. Okay, here's carbon's valence electrons, and the first thing I'm going to do is promote this electron up to here. So an arrow is an electron. Instead of using the circles for the orbitals, I'm using the lines. But these are, so we have an s orbital, one s orbital, three p orbitals. We promoted one up there. That has to happen before we can see how they combine to make a hybrid. The first hybrid I'm going to do is the sp3 hybrid. And when you have sp3 hybrids, what you're doing is you're taking all of these orbitals and you're combining. There's an s and 3p. And of course we took 4 orbitals, so we get 4 out. And they will each have an electron. And the geometry of this is tetrahedral. Okay, let's try a different one. What if we made an sp2 hybrid? So that would be taking these to make the sp2. And we use 3 orbitals, so we get 3 out, each with an electron, ready to form a bond. And the thing is, we have a p orbital that's left, and it's still there. It doesn't just go away, so I'm going to put it up here, and it has 1 electron in it. Let's talk about geometries. sp2, the geometry will be 3 electron groups is how you could say it. So this is trigonal, planar, and then you remember how p orbitals look, they're dumbbell shaped. They have the 2 lobes. Okay, let's see how we get an sp hybrid, what happens. So to get an sp hybrid, we're going to just take these 2, which will leave 2 of the p orbitals left over. So my sp hybrid will have 2 orbitals because I used 2 to make it. They'll each have an electron. And then I have p orbitals left. There are 2. Okay, so I've got 2 in the hybrid, 2 in the p orbitals. The hybrids are shaped linear because it's 2 electron groups is how you can think of it. And then the p orbital is still dumbbell shaped. Okay, let's look at some pictures now. And let's go ahead and add to our notes that these make the sigma and these make the pi. It's always the hybrid that makes the sigma bonds and the p orbitals that make the pi. So let's look at an example. So this has a double bond. This is ethene, also called ethylene. Okay, so the green here is the hybrid orbitals, the sp2. And wherever they overlap, like right here with the hydrogen, that's a sigma bond. So there's a sigma bond right between them. So I see 5 sigma bonds. Okay. And how many electrons, like let's just think of one carbon, how many electrons does it have over here? In the sigma, in the sigma bonds, or actually in the hybrid there, it has 3 electrons, one in each of these orbitals. Okay. Carbon has 4 valence electrons. The other one was in its p orbital. Okay, and do remember that this is, this is 1 p orbital. Okay, and this is 1 p orbital. It's just that it's stretched in between. They started reaching out and touching. Okay, this carbon is the same way. It has 3 electrons up here. So it has 1 there. I just put that one on bottom. It doesn't matter. How many bonds is this? It looks like it might be 2 bonds because it has that part and that part. But it is just 1 pi bond. Because there are just 2 electrons. Remember, 1 bond is sharing 2 electrons. And remember, it looks that way because this is 1 orbital when you do this. This is 1 orbital. And actually it kind of connects. But anyway, let's look at our other one. This is our sp hybrid. This is ethine, otherwise known as acetylene gas. It's used in welding. But so again, our green ones are the hybrid. And so we have a sigma bond there, there, there. Okay, and then as far as electrons go, each carbon has 2 electrons already. And the other 2 electrons are going to be in its p orbitals. So, because if it's sp, that means it has 2 p orbitals. And each p orbital, of course, has 2 lobes. And the other p orbital it has are kind of at a right angle to it. And so this is 2 p orbitals. And this is kind of turned, but the same concept. And in these orbitals, it has a total of, it has 1 electron in each orbital. I'm drawing sigmas instead of electrons. Okay, anyway, and then, they didn't show it because I think it makes it hard to look at, but these are connected in here because then you can't really see it. This one as well has, has 2 electrons. So how many bonds are shown here? Well, there are 4 electrons, so that's 2 pi bonds. So notice that a triple bond is 1 sigma This one was the sigma, and 2 pi. And if you want to go back, actually, and look at this bond is a sigma and a pi. So let's go to that trend on the next slide. So whenever you have a sigma bond, or a single bond involves the hybrid. It's a sigma. Okay, if you have a double bond, then it is a sigma and 1 pi. Sigma from the hybrid, the pi from the p orbital. If you have a triple bond, you have 1 sigma and 2 pi bonds. Sigma bonds can rotate. Pi bonds cannot. Let's add to this a little bit. Sigma bonds are from the hybrid, and pi bonds are from the p orbitals. Let's practice counting sigma and pi bonds. First, for the pi bonds, you look wherever you have a triple bond, that's 2 pi and a sigma. A double bond is 2 pi, 1 pi and 1 sigma. And so this one has 3 pi bonds. And then to count sigma bonds, really just every bond counts as a sigma. Every bond has at least 1 sigma in it. So 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, and then it asks to label each carbon with a hybrid type. So this carbon, the way we do this is we look at how many electron groups it has, and that tells us that how many orbitals in the hybrid. This one has 2. Remember, we have our order. So if it just has 2, we just need the first one, it's SP. And let's go ahead and say the geometry as well. SP is linear. Let's do this carbon as well. It's going to be SP, 2 electron groups. Let's do, and linear. Let's do this one. This one has 3 electron groups. And so it will be SP2 to get up to 3. Remember, counting exponents there to figure out how many orbitals. And the geometry of that is trigonal, planar. If you ever take organic chemistry, which many of you will, it's good to be able to look at a molecule and know the geometry. This one has 3 electron groups. Again, it's sp2. It'll be trigonal planar as well. Has 4 electron groups, so this is sp3, and it'd be tetrahedral.